Okay, so let's move on to Mars. And I just wanted to give you a quick update on the InSight mission, which is the most recent spacecraft to land on Mars. It's been there since just after Thanksgiving last year. And InSight is designed with two primary instruments. One is a very sensitive seismic experiment to look for Mars quakes and meteoroid impacts, and it can even measure storms in the atmosphere impacting the surface. And then the other experiment is called the heat flow probe, and that has a sort of a turkey baster sized probe that can penetrate about 5 meters deep into the surface, so 16, 17 feet deep. And the problem occurred shortly after they started sort of pounding this probe into the surface. It stuck only about 30 centimeters deep. And in July, they decided to pull the housing off of the surface so they could see if the probe was behaving the way that they sort of thought it was, which was that it should be about a third of its length sticking out of the surface. And this was what the expectation was, that the probe had gone in at an angle and essentially wasn't penetrating any deeper. And so here's the housing, and they removed that so they could see the top of the probe. And here's what they saw. So there indeed is the top of the probe. It's in a little divot, and it's sort of been pounding itself in a circle here, apparently. Here's the data cable that connects it to the spacecraft. And what the hope was is that the surface goes dark at night, and that the surface was just very cohesive. And so it's like the difference between, say, a cup of salt or sugar and a cup of talcum powder or plaster of Paris. If you stick your finger in both of those and pull it out, the plaster of Paris, you're going to leave a hole behind, and the sugar or the salt collapses and fills the hole. And that's what they had expected to find. And the probe has a little sort of a pile driver mechanism in it, and so it pounds and then winds itself back up and pounds again, and slowly that drives itself into the surface. But if it's a very cohesive surface, then it can actually make this void around itself, and still, when it pounds down with the little weight inside, it rebounds, and so it's basically bouncing up and down in the hole. And that's what they think they found. So what they were hoping they could do, I'm sorry, that's an extraneous slide, is put the arm, the robot arm, the sample scoop, right next to the probe and push the arm down, and that would collapse the hole. And this is what they saw. After doing that, the hole was partially collapsed, but it still wasn't filled in. And so the thinking is that actually the surface is very crusty. And so there's a layer of sort of cemented material at the top, and that is impeding the progress of the probe. And this is an image of material like this that the Opportunity rover saw back in 2004. And so that's where we were last month. And at that point, Mars, the orbit of Mars carried it behind the sun relative to the Earth. And so we haven't had communication for last part of August and up until last week. And so Mars is now visible from the Earth, and we're communicating again. But so far, they haven't decided what to do next. The highest likelihood is they're going to try a variant on this where they actually push this down right next to the probe and then push sideways on the probe to have the sample scoop provide some friction and see if they can make any progress that way. But they're still doing tests on the ground and deciding how to proceed. So now that they're back in communication, hopefully by 60 Minutes at the end of next month, we'll have a progress report on what they've decided to do, and hopefully they've actually tried it. So I'll leave that, and we'll move to another part of Mars, the Curiosity rover. Today is day 2537 after landing. So it landed in August of 2012, and it's been roving Mars ever since. The general lay of the land is the landing site is inside a 100-kilometer diameter impact crater called Gale, and this crater has evidence of water flow. There's channels coming into it. There's a big channel here, and the thinking is this at one point was filled with water, and right in the center of the crater is a pile about 5 kilometers high of sedimentary rocks. And so Curiosity landed right here. The intent has been to sample material and slowly climb the lower parts of this mountain. And so here's their progress, and I don't expect you're going to be able to see this, but this was the landing point. They have, we have a loose connection on my computer, so hopefully it's going to come back here. This dark area is sand dunes, and they didn't want to drive directly across the dunes for fear of getting stuck. But Mount Sharp, that mountain, now my pointer has died as well. Mount Sharp is toward the bottom here, and where they are right now, there's this ridge. Okay, come on. Can we try the just plugging and unplugging the adapter? Let's see if that does anything for us. Or just hit the up arrow. other up arrow. Okay, so let's try that. So this is a view of Mount Sharp from where they're sitting about a month ago, and there we go. This area from orbit, they've detected a high abundance of clay minerals, and clays are exciting to geologists because it indicates that the surface rocks have been wet, and there's water involved in eroding them. And so they've been, let me try backing up here and see if this will work. This ridge right here is the entire thing is very clay rich, at least from orbit. And so they've been spending a lot of time driving along that ridge. And this is a view off in the distance of where they're hoping to go. So they're sitting, at the bottom of the screen here, and they're hoping to do something like this. And this is a little animation of how that will happen. Here's where they're actually sitting right in this area, and this will be the future path up the side of the mountain. And they actually will end up climbing one of those gullies that looks like it was eroded by water. And so some closer up views here. This is an outcrop on that ridge, and they've gotten really close to these sedimentary, these layered rocks. And I guess my pointer is not going to let me do that. So if we can advance the slide, or try to anyway. There we go. So this is a closer up view of one of the rocks that they've been studying. And there we go. Well, I have a cursor. There we go. Okay. So here's a scale bar. So this is about 60 centimeters. And this is, I don't know, about, probably about a meter or so long. And here's a closer up view of all these little layers in the rock. And each one of those layers is a different episode, likely of flooding of this area and converting the minerals that were there into clay. And so they've been analyzing this for the last several months, and one of the things they've decided to do just in the last couple of weeks is to drill several sample holes. And so once again, my pointer is gone. What you're seeing right in the center of the screen there is the drill bit of their little sample drill, and it drills a hole that's about the diameter of a 50-cent piece, if you even remember what 50-cent pieces look like. And they drill and extract powdered material from the drill hole, and they can analyze the chemical makeup as well as the minerals that are involved in that. And so here's what they've been doing the last couple of weeks. So this was about 8 days ago. And they first drilled a pilot hole in this to make sure that the rock didn't just sort of fracture. And then they came back and drilled the hole at the, at the upper right, and collected samples from that. And so about 3 days ago, they loaded the samples into the analysis instruments on board. This is a closer up view. Whoa. Okay, this has a mind of its own. This is a close-up view of that hole that was at the upper right, and you can see how crusty this material looks, and it definitely fragments very easily. And so this is, they believe, clay material. And this was an image taken just this morning, and well, if I can get this to move, maybe. So right in here are the tire tracks that it left as it was approaching this ridge, and so they expect to keep on along this ridge and then follow that path that I showed in the earlier slide and work their way up the side of the mountain. So the whole point of this is that the material that's lower on the mountain would be the older material, and as they get higher and higher, it would be younger episodes that laid down the material. So you get a history of the environment in this area. And so this is the recap. Again, it's day 2537. They've driven about 21 kilometers since landing, and this amazes me. They've returned over 600,000 images so far. Okay, and this is the looking ahead part of the talk. So the next big Mars mission will be launched next July, and it's called Mars 2020. It's the structure of the spacecraft is almost an identical twin of Curiosity. It's got different wheels, and it's got very different set of experiments on board. And it's designed to look for evidence of biology on the surface, either the chemistry of past biology, or if there are microbes there currently, to be able to detect them as well. And to also collect samples, and in the mid to late 2020s, they expect to have a sample return mission where another rover will get close to, will land nearby and then pick up the samples that were collected by this rover, launch them into Mars orbit, get picked up by an orbiting spacecraft and launched back to the Earth. And so the United States, or NASA, and the European Space Agency have signed an agreement to both work on this and proceed over the next decade to make that happen. And this is when the CIA got involved in this and classified all the information. So one of the interesting sort of the spiffy things, I guess you'd say, on this mission is they're going to do an engineering test of a little helicopter to see how well that will work for future Mars missions. And so that's an artist's view of that sitting on the surface. It's solar powered. They expect it to be able to go several hundred meters over the course of maybe 10 hops after it's deployed. And this is a view of the actual flight model. And here's the sort of to scale. It's bigger than your average drone for sure, but it weighs something like 5 kilograms, so it's very light. And its position on the lander is actually on the belly of the spacecraft. And so this is the 2020 spacecraft. It's turned upside down, so this is the bottom of the spacecraft, and there's the little helicopter attached to the base of it. And so the way this will work is they drive along, they'll select a spot, and this will be lowered from the belly onto the surface. The rover will drive away from it, and it will then be commanded to helicopter away, essentially a little drone. And it will communicate to the Earth via a radio link to the rover. And so this is what's happened just in the last week. They've attached all of the experiments and most of the hardware to the rover, and the next thing they want to do is determine the balance of the rover, the actual mass so far. And you do that by putting the rover on a turntable and spinning it, and you can determine the center of mass and all of the details they want. So that's been happening, and they're sort of nearing the end of the fabrication of the rover. I think right around the first of the year, they will ship it to Kennedy Space Center, where it will be prepared for attaching to the Atlas V rocket and sent on its way. And so one of the things, and I'll put this up right at the very end with the website, but if you're interested, there's a NASA website. You can put your name and sort of details on a little chip, electronic chip on the rover, and sent to Mars. And this The window of opportunity for this ends on September 30th. So you have 5 days to submit your name. But the interesting thing here is there's 9,750,000-ish names that have been submitted so far. So let's add several hundred from DM&S and put this over the top to 10 million. So this is the details for 2020. The launch window is the 17th of July through the 5th of August 2020, and the landing will be on in mid-February of 2021. So we'll be updating this as time goes on and keep you posted about what's happening in the preparations for this mission.